Good day, everyone, and you are welcome to the world of mathematics. Today, we are going to consider plane mensuration, plane mensuration, plane shapes. Plane shapes are two-dimensional shapes of length and breadth. Examples of plane shapes are we have triangles, rectangle, square, trapezium, parallelogram, rhombus, kite, and circle. So you are looking at the special type of plane shape, which is circle. So a circle describes a fixed point on plane at a constant distance from many other points. So the fixed point here is the center of the circle. So we have circles as different parts, which we have some of them here. We have circumference. Circumference of a circle is a line round the circle that is the total length, the length of a circle. The perimeter of a circle is the same thing as what? Circumference. Now we have diameter. Diameter is a line that divides the circle into two equal half semicircle. So it's a line that moves from one edge passing through the center to the other edge. And we have radius. Radius is half of a diameter. So it's a line that drawn from the center of the circle to any part of the circumference. And we have a chord. And a chord is a line that divides a circle into two segments. Major segment and minor segment is a line that moves from one edge to the other but without passing through the center. It is shorter than diameter. So sector. A sector of the circle is a region bounded by two radii and an arc. So we have segment. As I said earlier, segment is a region bounded by an arc of a circle and what? And a chord. We have minor segment and we have major segment, and we are still going to talk about that later. So we have arc. Arc is part of circumference. So look at this diagram now. So the length around the circle is the circumference. The line that divides the circle into two equal halves is diameter, and half of that is radius. Now we are going to talk about arc of a circle. An arc of a circle is a portion of the circumference of a circle that is cut off from the part of a circle by two radii of the circle itself. Now, length of an arc of a circle. Anytime you want to determine the length of an arc of a circle, so you must consider two basic dimensions, which are the radius of the circle and the angle sustained by the arc at the center. Those two things are very, very important anytime you want to determine the length of an arc of a circle. So when you know the radius and the angle sustained at the center, then you are good to go. Now, look at this diagram. We have in the first circle there, we have arc PRQ, and that is minor arc. So the angle sustained at the center is theta, and we also have PSQ, that is major arc. We have the minor arc here, PRQ, and here we have the major arc, PSQ. Now, the sustained theta at the center of the circle. So the length of an arc of a circle now is equal to theta over 360. The angle sustained at the center over the total angle in a circle times the circumference of a circle, which is 2 pi r. That is just the formula to find the length of an arc of a circle. Now we move to example 1. We have example 1 says an arc of a circle of radius 8 cm sustain an angle of 85 degrees at the center of the circle. Now find the length of the arc. Take pi to be 22/7. So anytime you are given the value for pi, make sure you use the value you are given. So the length of an arc is equal to theta over 360 times 2 pi r. The theta you are given there is 85 degree over 360 times 2 times pi is 22 over 7 times radius is 8. So multiply 85 by 2 by 22 by 8 to give us 29,920 divided by 360 times 7 give us 2520. So we now divide 29,920 by 2520, we have 11.87 centimeter to 2 decimal places. Now example 2. The pendulum of a clock is 5 centimeter long and swings through an arc of 8 centimeter. Through what angle in degrees does the pendulum swing? Take pi to be 22 over 7. Here you are given the radius, you are given the length of an arc, but you are not given the angle. That is say, it said through what angle in degrees does the pendulum swing. So you are looking for angle now. So you are given the length. So you are still going to apply the formula for length of an arc of a circle, which is theta over 360 times 2 pi r. But here you are given the length, so that is 8. Is equal to, you are not given theta now, so you write theta over 360 times 2 times 22 over 7, which is value for pi, times radius, which is 5. So we now have 2 times 22 times 5 times theta will give us 220 theta over 360 times 7 give us 2520. So now I have 8 is equal to 220 theta over 2520. Then when you make theta the subject of the formula, so you are now going to have 8 times 2520 over 220. From there, 8 times 2520 give us 20160 over 220. Now divide it, 20,160 divided by 220, you have 91.64. So if you approximate that to nearest degree, you have 92 degrees. So the angle of that pendulum is 92 degrees. Now we are moving to perimeter of a sector. As I've said earlier, a sector is a region of a circle bounded by two radii and an arc of a circle. Now look at the first diagram here, the first circle. We have arc AB, that's arc AB, and we have radius from this A to center O. We have radius here. From B to center O, we also have radius. So that is two radius and this arc AB. So that region now, if you bring it out, that is what we call a sector. And that is minor sector. While the remaining one is the major sector. Now, if you want to find the perimeter of a sector, it is addition of what? The three lengths, the two radii and the what? And the length of an arc of a circle. That's why we have it here that for any circle with center O and radius r from which a sector AOB is formed, the perimeter of the sector is the sum of the two radii and the length of the arc AB, since the perimeter is the distance around a given shape. The total length of a shape is called perimeter. Now from there we have the perimeter is equal to, the perimeter of a sector is equal to 2r plus L. The length L there is what? Length, let's say length of an arc of a circle, which is theta over 360 times 2 pi r. Therefore, the perimeter of a sector is equal to 2r plus theta over 360 times 2 pi r. So that one leads us to example 3. It says that the angle of a sector of a circle of radius 5.5 centimeter is 60 degrees. What is the perimeter of the sector? Take pi to be 22 over 7. So the perimeter of the sector is what? 2r plus length of an arc. Now the radius you are given there is 5.5. So you have 2 times 5.5 plus length of an arc is what? Theta over 360 times 2 pi r. So now I have 2 times 5.5 plus the angle you are given is 60. So 60 over 360 times 2 times the value for pi, which is 22 over 7, times the radius, which is 5.5. So we now multiply 60 by 2 by 22 by 5.5. That give us 14,520 over 360 times 7. That give us 2520. And in the other side, the 2 times 5, sorry, 2 times 5.5 give us 11. So now I have 11 plus 14,520 over 2520. So we have 11 plus, when you divide 14,520 by 2520, we have 5.76. So add 11 and 5.76 together, we have 16.76 centimeter. Now, example 4, we have OS and OY are radii of a circle, center O. If OS is 4 centimeter and angle XOY is 60 degree, calculate, correct to the nearest O number, the perimeter of sector SOY of the circle. Take pi to be 22/7. Now, this is the diagram here. We have XOY, that is the sector now. So the angle sustained at the center, which is SOY, is 60 degree, and the radius of that circle is 4 centimeter each. So the radius is equal to, so radius SO is equal to, oh sorry, the radius OS is equal to radius OY, so 4 centimeter each. Now, to find the perimeter here, we have 2r plus length of an arc, and the radius you are given here now is 4. So 2 times 4 times the angle subtended at the center of the circle is 60. So 60 over 360 times 2 times 22/7 times 4. So 2 times 4 give us 8, plus 60 times 2 times 22 times 4 give us 10560 over 360 times 7 give us 2520. So now I have 8 plus, so 10560 divided by 2520 will give us 4.19. So add it together. So 8 plus 4.19 give us 12.19. And it asks us to take it to the nearest whole number. So we have 12 centimeter to the nearest whole number. Now, last thing we are going to talk about today is area of a sector. Now, area of a plane shape is the region bounded by the shape. Area of a plane shape is the region bounded by the shape. So, for example, now in a football field where the 22 players are playing with, together with the referee, is the area of that football field. Now, look at this diagram here. We have, in the first diagram, we have AOB. So if you cut that out from that circle, so that region AOB, what to bring out is a sector, and the inside of that what you brought out is called a sector, and that region is the area of the sector. Now, the area of the sector AOB of the circle radius R of center O in the figure above is given as theta over 360 times area of the circle. It's more or less like length of an arc of a circle. So the angle sustained at the center over the total angle of a circle multiplied by the area of a circle give us the area of a sector. Simple as that. So the area of a sector now is what? Theta over 360 times pi r square. That is the area of a circle, pi r square. Now look at example 5. A sector of an angle 120 degree is cut out from a circle of radius 13.5 centimeter. What is the area of the sector cut out? Now, the angle at the center of that circle is 120 degree. The radius is 13.5 centimeter. Then it's very simple. The area of the circle there is equal to theta over 360 times pi r square. So the angle there is 120 over 360 multiplied by pi 22/7 multiplied by the radius 13.5 times 13.5 because it's r square. So now I have 120 times 22 times 13.5 times 13.5 give us 481140 divided by 360 times 7 give us 2520. So when you now divide that, 481140 divided by 2520 give us 190.93. So approximate to one decimal place is 190.9 centimeters square. Remember to put square there because we are working on area now. The unit of area is square. Now, we are going to look at example 6, the last example for today. And it says that the area of a sector of a circle is 246.4 centimeters square. If the radius of the circle is 14 centimeters, find the angle subtended at the center of the circle. Now, in this question now, you are given the area 246.4 centimeters square. You are given radius 14 centimeters and the pi is equal to 22/7. So what is not known to us here now is the angle theta. So you are still going to apply the same formula. Area of a sector is equal to 360, sorry, is equal to theta over 360 times pi r square. Now you are given the area which is 246.4, you put it there, is equal to, you are not given theta, so you put your theta over 360 times the value for pi 22/7 times radius 14 times radius again 14 because it's r squared. So you now have theta times 22 times 14 times 14 will give us 4312 theta over 360 times 7 give us 2520. So now have 246.4 is equal to 4312 theta over 2520. Therefore you cross multiply, so you have 4312 theta multiplied by 1 give you 4312 theta is equal to, so if you multiply 246.4 by 2520 you have 620928. Therefore you divide both sides by 4312 to get your theta. So we now have 620928 divided by 4312. So that gives us 144 degree. So the angle of that sector is 144 degree. So that is exactly how to get the angle when you are given the area and you are given the radius of a sector. So we are going to stop here for today. Next time we move on from where we stopped today. God bless you. Goodbye.